Hi Calc AB, here's page 38 of your binder. Even though this problem says a graphing calculator is required, I'm still going to do this without a graphing calculator, just to show you that you can do this by hand. Karen rides her bicycle along a straight road from home to school, starting at home at time t equals 0 minutes and arriving at school at time t equals 12 minutes. During the time interval 0 to 12 minutes, her velocity v in miles per minute is modeled by the piecewise linear function whose graph is shown above. Find the acceleration of Karen's bicycle at time t equals 7.5 minutes. Indicate units of measure. All right, part A. Find the acceleration of Karen's bicycle at time t equals 7.5 minutes. So the acceleration at 7.5 minutes is the same thing as the derivative of velocity at 7.5 minutes, and I think that's an important connection to make on your paper because they're giving us a graph of velocity. The derivative of velocity translates into the slope of the tangent line at 7.5 minutes, and it's convenient because this is a line, so we need to find the slope of this line. We're going to go down 0.1 over 1, so negative 0.1 over 1, and now we can consider the units. Velocity's units are miles per minute, and our denominator's unit is time, so that'll also be minutes. So our acceleration at 7.5 minutes is negative 0.1 miles per minute squared. You're allowed to leave it as miles per minute, or you can write it like this. Part B. Using correct units, explain the meaning of the integral from 0 to 12 of the absolute value of v of t dt in terms of Karen's trip and find the actual value of this. So the absolute value is going to make all of your velocities positive, which means that you don't actually care about the direction that Karen is moving. You just care about all of the distances that she's traveling adding up. So this is a distance traveled phrase. Looking at the graph, this right here is a negative region. It's the only negative region. And so just to be able to think about it, that means these velocities are now positive. That's what the absolute value would do. And then the integral would be adding up all of these areas from 0 to 12. So I'm going to take a second and I'm going to fill this in with areas using formulas for triangles or trapezoids, rectangles, and I think you should pause the video and also spend some time making the areas too. All right, these are the areas that I get. And so now this is just a matter of adding up all of those values. So here we go. This ends up being 1.8 miles. Remember that if you're on the AP test on a no calculator part, that you could leave your answers in terms of add, subtract, multiply, and divide, so it would be okay to leave it just like this in a long string and not worry about getting anything wrong. But just to conclude the problem, it is 1.8. They did ask us to use correct units, and the reason that the units are miles is because this is a distance traveled question. All of your areas, every single one of your area calculations is going to be doing a miles per minute unit and multiplying them by minutes. So your miles over minute times minutes, the minutes will cancel out and you're left over with miles. We do need to write the meaning like a sentence describing all the things that we've just understood. So between 0 and 12 minutes, Karen travels a distance of 1.8 miles. Part C. Shortly after leaving home, Karen realizes she left her calculus homework at home and she returns to get it. At what time does she turn around to go back home? So this is a change in direction problem. So when you think back to particle motion, when we were moving to the right, our velocity was positive. I'm just writing these notes here. let me write this again. So positive velocity means traveling to the right, and negative velocity means that you're traveling to the left. So when we talk about a change in direction, so changing from right to left, it means that your velocity is changing from plus to minus, or you could say the other way around. Now, the context of the question says, Karen realizes she left her calculus homework at home and she has to return to get it. So she's already been moving for some amount of time away from her home. So looking back up here at the diagram, this is the place where Karen's velocity changes from positive to negative. It could be confusing, like some people might want to say that it's here because it looks like she's changing direction, but that's an incorrect idea because these velocities are positive. Yes, this velocity is more than right here, but it's still positive, which means Karen is still moving further away from her home. So it's not until right here that she says, oh no, I forgot my homework and I have to actually go back, that's how we know she's changing direction, when our velocity changes from positive to negative. So we just need an idea here, and this right here is not something that you need to write. I just wrote it down so that we would understand the context of our idea. But at t equals 2 minutes, Karen returns home because her velocity changes from plus to minus. Part D. Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by the function w given by w equals pi over 15 sine of pi over 12t, where w is in miles per minute for 0 to 12 minutes. Who lives closer, Karen or Larry, and show the work that leads to your answer. So Karen lives this far away from school. And this is taking into account all the velocities that she's had. So we had some positive velocities, but then we also had some negative ones where she came back. And so that negated how much she had already walked. So all of that's taken into account when you don't have the absolute value of ours. So take a second, go back to your areas, and come up with Karen's distance from school. I'm getting 1.4 miles from school. Larry lives in a similar calculation, so the integral from 0 to 12 of w of t dt. Now, again, this is a calculator problem, but I'm going to not use my calculator and work through this one by hand. So here we go. This is the integral of pi over 15 sine of pi over 12t dt. I see the pi over 15, that's a constant, so I can factor that outside of my integral. And then I see that sine is a really nice function to find the antiderivative of. This is an easy calculation to work through, but then I'm like, oh no, I've got this pi over 12t on the inside, which means this is a u substitution problem because this is a function of a function. So du is pi over 12 dt. And remember, with all of these u substitution problems, you can always manipulate the constants, but you can't do anything with any variables that are over here. You'd have to leave variables with the differential. So dt equals 12 du over pi. The next thing we have to consider are the bounds. So we have our upper bound that we need and our lower bound that we need. 12 gets replaced over here. So 12 over 12 times pi will just be pi. The lower bound will be 0. So now we can rewrite the integral as pi over 15 times the integral from 0 to pi sine of u times, remember that dt is this substitution. So we have 12 du over pi. This is another constant that can be factored out. So pi over 15 times 12 over pi times the integral of 0 to pi sine of u du. All right, so now we're ready. Pi's cancel out. 12 over 15 is 4/5. The antiderivative of sine, or where sine comes from, like sine is the derivative of this function, is negative cosine. And you evaluate that from 0 to pi. I'm going to throw the negative on the outside just so I don't have to worry about the negatives here. Remember, evaluating integrals, you evaluate, whoops, I forgot a u. You evaluate the expression up high minus the expression down low. Cosine of pi is -1. The cosine of 0 is +1. So this becomes 8/5, which is the same thing as 1.6. Our units are miles. So that was a very long problem. Larry lives 1.6 miles from school. We answered earlier that Karen lives 1.4 miles from school, and the question is, who lives closer? So I would finish my idea and say Karen lives closer, with all of that work to show the support of our answer. All right, that's page 38.